Welcome friends, this is Quality Improvement in Math Education Project QIME video based PPT presentation. My topic of presentation is trigonometry. My name VASANT Dadu Sutar and my registration number is MTE114. My school name is Mohanrao Patangrao Patil Vidyalay Borgaon. District Sangali, guided by Professor Inder K. Rana, IIT Bombay. Task 1. Observe and explore. Now we see the video related with trigonometry. Now we see another video.
That we can do this with all kinds of word problems because right triangles are everywhere. That's right, right triangles are everywhere. In fact, they're in all kinds of sports, right triangles are in origami and woodworking. They even are in ancient artifacts and history, and they are even in current artifacts of current history of nations that exist today, and all kinds of symbols of national pride have right triangles built into them. And even the way that you fold some of these symbols of national pride and store them have to do with right triangles. In fact, right triangles also happen when the sun casts a shadow. Right triangles also happen when a plane up in the sky has to communicate with an air traffic control tower. And when satellites up in the sky communicate with the Earth. They make right triangles. In fact, the Earth and the Sun and the stars, way, way, way outside of our solar system, can make right triangles, and that's how we calculate astronomical distances. And it's also how we can calculate not so astronomical distances, like how far a boat is off of the shore. That's another right triangle scenario. Where else are right triangles? Well, right triangles are in roller coasters. Well, we're not going to talk about ladders. Right triangles are even in ugly sweater designs. They're in Pythagorean-shaped birdhouses. Right triangles are even in the way some of you cut your sandwiches. And, of course, right triangles are found in the design of the famous hypotenuse. Oh, that was a bad one. Where else are they? Interior design uses right triangles all the time. And exterior design uses right triangles all the time. And in order to make those designs come to life, construction and architect workers use right triangles all the time. Right triangles, they're everywhere.
In above videos, we had seen that trigonometry has uses in engineering, architecture, physics, and geography. Trigonometry. Definition of trigonometry. Tri means 3, gona means sides, and metron means measures. That means measurement of enclosed figure having 3 sides. Observe the figure. Here, triangle ABC is right angled triangle. Angle B is right angle. Angle C is 30 degree and angle A is 60 degree. Observe the another figure. Here triangle ABC is also right angled triangle and angle C is 90 degree, angle A is 45 degree and angle B is 45 degree. Now we see triangle ABC is right angled triangle. Side AC is called hypotenuse. In case of angle C, AB is opposite side and side BC is called adjacent side. Now we see some trigonometric ratios. Sine of angle C is equal to opposite side upon hypotenuse. Means opposite side in case of angle C, opposite side AB upon hypotenuse AC. AB upon AC. In Marathi, Saba Chhed Karna. Next, cosine, cos of angle C. Cos C is equal to adjacent side upon hypotenuse. BC upon AC. In Marathi, Laba Chhed Karna. Laba Chhed Karna. Then tan of angle C is equal to opposite side upon adjacent side. Means AB upon BC. Marathi Saba Chhed Laba. In Marathi, sin C Saba Chhed Karna, cos C Laba Chhed Karna and tan C Saba Chhed Laba. सबा म्हणजे समोरील बाजू, लबा म्हणजे लगतची बाजू आणि कर्ण. Then cot C. Cot C is inverse of tan C. Therefore, cot C is equal to adjacent side upon opposite side. Means BC upon AB means laba chhed saba. Then sec C. Sec C is equal to hypotenuse upon adjacent side. Means AC upon BC. And this is inverse of cosine. Then cosec C. Cosec C is equal to hypotenuse upon opposite side. Means AC upon AB. AC upon AB. Karna chhed saba. And cosec C is inverse of sin C. Task 2. Define and prove. Now we see the relation between trigonometric ratios. If A and B are inverse of each other, then we know that product of A and B is equal to 1. Therefore, A is equal to 1 upon B and B is equal to 1 upon A. Now remember the order of these trigonometric ratios. Sin, cos, tan, cot, sec, cosec. Sin, cos, tan, cot, sec, cosec. Then sin x and cosec x are inverse of each other. Cos x and sec x are inverse of each other, and tan x and cot x are inverse of each other. Therefore, product of these ratios is equal to 1. Now, interrelation between sin and cosec. Sin x and cosec x are inverse of each other. Therefore, product of these two ratios is equal to 1. Therefore, sin x into cosec x is equal to 1. Therefore, we get sin x is equal to 1 upon cosec x. Also, cosec x is equal to 1 upon sin x. Now we see interrelation between cos and sec. Cos and sec are also inverse of each other. Therefore, product of these two is equal to 1. Therefore, we get cos x into sec x is equal to 1, and cos x is equal to 1 upon sec x, and sec x is equal to 1 upon cos x. 1 upon cos x. Now we see interrelation between tan and cot. Tan and cot are also inverse of each other. Therefore, their product is equal to 1. Therefore, we get tan x into cot x is equal to 1, and tan x is equal to 1 upon cot x, and cot x is equal to 1 upon tan x. Now we see trigonometric identities. Here, triangle ABC is right angled triangle, where angle B is right angle and angle C is x degree. In triangle ABC, by Pythagoras theorem, AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Dividing equation 1 both sides by AC square, we get AB square upon AC square plus BC square upon AC square is equal to AC square upon AC square. Then we get AB upon AC bracket square plus BC upon AC bracket square is equal to AC upon AC bracket square. Therefore, we get AB upon AC is equal to sin x bracket square plus BC upon AC is equal to cos x bracket square and AC upon AC is equal to 1 bracket square is equal to 1. Therefore, sin square x plus cos square x is equal to 1. This is first identity. Similarly, dividing equation 1 by BC square both sides, we get sec square x is equal to 1 plus tan square x. This is second identity. And dividing equation 1 both sides by AB square, we get cosec square x is equal to 1 plus cot square x. How could I easily find the trigonometric values of angles? Is it possible? Yes, it is possible. For this, consider your left hand in front of you. This is little finger. This is the ring finger. This is middle finger. This is index finger. And this is thumb. Assign that angles to all 5 fingers as follows. This is 0 degree. This is 30 degree. This is 45 degree. This is 60 degree. And this is 90 degree. Now we see some rules. For sine ratio, first we see how to count fingers. Suppose this is 45 degree. Then in clockwise direction, there are 2 fingers, and in anti-clockwise direction, there are 2 fingers. Similarly, for 60 degree, in clockwise direction, there are 3 fingers, and anti-clockwise direction, there are 1 finger. For sine, take square root of clockwise direction fingers and divide it by 2. For cos, take square root of anti-clockwise fingers and divide it by 2. For tan, take square root of clockwise fingers divided by square root of anti-clockwise fingers. For cot, we can write inverse of tan. Therefore, anti-clockwise root of anti-clockwise divided by root of clockwise. For sec, sec and cos are inverse of each other. Therefore, we write 2 upon anti-clockwise root of anti-clockwise fingers. For cosec, cosec is inverse of sine. Therefore, we write 2 upon root of clockwise fingers. We see some examples. Sine 0. This is 0 degree. We count clockwise fingers. There are 0 fingers. Therefore, we take root 0 and divide it by 2. Root 0 upon 2 is equal to 0. Therefore, sine 0 is equal to 0. For sine 40 degree, 45 degree, sine 45 degree. This is 45 degree. In clockwise direction, there are 2 fingers. Taking square root of 2, we get square root of 2 divided by 2 is equal to 1 upon root 2. Next, cos 60. This is 60 degree. And for cos, we measure anti-clockwise fingers. There are 1 finger, therefore we take square root of 1 divided by 2 is equal to 1 upon 2. Tan 45 degree. This is 45 degree angle. For tan, clockwise direction 2 fingers, anti-clockwise direction 2 fingers. Therefore, taking square root of 2 divided by square root of 2. Square root of 2 divided by square root of 2 is equal to 1. Cot 30. This is 30 degree angle. For cot, we measure anti-clockwise first and then clockwise. Anti-clockwise 3 fingers and in clockwise direction 1 finger. Therefore, we write root 3 upon root 1 is equal to root 3. Cot 30 is equal to root 3. Sec 30 degree. This is 30 degree angle. For sec, we write 2 upon root anti-clockwise fingers. Therefore, 2 upon anti-clockwise fingers there are 3 fingers. Therefore, we write 2 upon root 3. And cosec 0. 0 degree angle is here. For cosec, we count clockwise in clockwise direction. There are 0 fingers. Therefore, we write 2 upon root 0 is equal to 2 upon 0 and it is not defined. Task 3. Apply and evaluate. Consider example 1. If cos theta is equal to 2 upon 2.5, then find the values of the remaining trigonometric ratios. Solution. Cos theta is equal to 2 upon 2.5 is given. Using sin square theta plus cos square theta is equal to 1. We get sin square theta plus 2 upon 2.5 bracket square is equal to 1. Therefore, we get sin square theta plus 4 upon 6.25 is equal to 1. Sin square theta is equal to 1 minus 4 upon 6.25. Sin square theta is equal to 6.25 minus 4 upon 6.25. Therefore, we get sin square theta is equal to 2.25 upon 6.25. Taking square root of both sides, we get sin theta is equal to 1.5 upon 2.5. Now tan theta is equal to, we know tan theta is equal to sin theta upon cos theta, is equal to 1.5 upon 2.5 divided by 2 upon 2.5. We get 1.5 upon 2. Cot theta. Cot theta is inverse of tan theta, and tan theta is equal to 1.5 upon 2, and inverse of it 2 upon 1.5. Sec theta. Sec theta is inverse of cos theta, and value of cos theta is 2 upon 2.5, and inverse of this is 2.5 upon 2. Cosec theta. Cosec theta is inverse of sin theta. Value of sin theta is 1.5 upon 2.5, and inverse of this is 2.5 upon 1.5. Now we consider example 2. If cot theta plus 1 upon cot theta is equal to 7, then show that cot square theta plus 1 upon cot square theta is equal to 47. Solution. Cot theta plus 1 upon cot theta is equal to 7. This is given. And we have to show that cot square theta plus 1 upon cot square theta is equal to 47. Therefore, we square the both sides. Therefore, taking square of both sides, we get cot theta plus 1 upon cot theta bracket square is equal to 7 square. Using a plus b bracket square is equal to a square plus 2ab plus b square, we get cot square theta plus 2 into cot theta into 1 upon cot theta plus 1 upon cot theta bracket square is equal to 49. Therefore, cot square theta plus 2. Here, cot theta into 1 upon cot theta is equal to 1, and 2 into 1 is equal to 2, plus 1 upon cot square theta is equal to 49. Therefore, cot square theta plus 1 upon cot square theta is equal to 49 minus 2. This plus becomes minus, plus 2 minus 2. Therefore, cot square theta plus 1 upon cot square theta is equal to 47. Now we see exercise. Question: solve the following examples. Thank you.